Sutures can be divided into absorbable sutures and non-absorbable sutures. Absorbable suture means the term is self-explanatory. It is absorbed in tissues because of phagocytosis or enzymatic digestion. And non-absorbable means it is not absorbed. It means it is going to persist in tissues for indefinite period of time. Okay, so see the differences. First, types of sutures. So absorbable sutures and non-absorbable sutures. Non-absorbable. Okay. So first important point: absorbable sutures are absorbed in tissues because of enzymatic digestion and phagocytosis, right? And non-absorbable sutures, these are going to persist for indefinite period. Okay. Now there is further division that absorbable and non-absorbable sutures are further divided into natural and synthetic. So what are natural absorbable sutures? Chromic catgut and catgut. So catgut and chromic catgut are natural absorbable sutures. What are natural non-absorbable sutures? Silk and linen. Okay. So see the natural absorbable sutures is catgut and chromic catgut. Catgut and chromic catgut. Okay. And natural non-absorbable suture, and this is silk and linen. Okay. After that, what are the synthetic absorbable sutures? So synthetic absorbable sutures include polyglycaprone, polydioxanone, vicryl, dexan. And what are the synthetic non-absorbable sutures? Proline, ethylene, nylon. Right. This list is important because it is frequently asked, so you have to remember synthetic absorbable sutures and synthetic non-absorbable sutures. Right. So synthetic absorbable sutures: polyglycaprone, polydioxanone are also known as PDS in short form. Okay. Vicryl and dexam. Right. Now see, important questions. Polyglycaprone is also known as monocryl. Vicryl is also known as polyglactin, and dexan is also known as polyglycolic acid. You have to remember the names. So polyglycaprone, the other name, it's also known as monocryl. Okay. Vicryl, the other name is polyglactin, and dexan, other name is polyglycolic acid. Simple. So how to remember the mnemonic is, can you see, PVD? So PVD means polyglycaprone, polydioxanone, vicryl, dexan. So how to remember the mnemonic is PVD. Now synthetic non-absorbable sutures: proline. What is the other name of proline? It is also known as polypropylene. Second is polyester, and ethylene, nylon. Clear? So how to remember? Here the mnemonic is pen. So the mnemonic for synthetic non-absorbable suture is pen. So pen means proline, polyester, ethylene, nylon. Clear? So this is important. After that, sutures are further divided into monofilament and polyfilament sutures. Okay. Now see the difference. In monofilament suture, there is a single strand of fiber, smooth and strong. So if there is a single strand of fiber, this is monofilament. And if in the suture there are multiple strands braided together. So if, can you see, multiple strands are braided together. Have you seen a rope? So you have seen there are multiple strands. So here you can see multiple strands braided together. So in between strands, can you see there is space? And because of this space is known as crevices. So because of this space, what's the problem? There is increased risk of infection. If we see the monofilament sutures, in monofilament sutures, since it is smooth and strong, there is no crevices, so it is associated with decreased risk of infection. But in polyfilament sutures, since there is crevices or presence of space between the strands, there is increased risk of infection. Second problem, monofilament suture. What is the problem? The knots are less stable. And that's why in monofilament sutures we take how many knots? 6 to 8 knots. And in polyfilament suture, the advantage is that knots are more stable, and that's why 3 to 4 knots are sufficient. To see the differences between monofilament and polyfilament sutures. Okay. So monofilament means mono, so there is single strand. So these sutures have single strand, and these are smooth and strong. The good thing that since there is a single strand, decreased risk of infection because there are no crevices. So crevices are not there. But the problem, the knots are less stable. So the knots tied become loose. So knots can become loose. That's why these are less stable. How many knots we take? That's why we take 6 to 8 knots with monofilament sutures. If you have seen laparotomy, whenever we are closing the rectus sheath in laparotomy, you have seen the surgeon is closing the rectus sheath with proline, and you have seen that how many knots surgeon is going to take? Generally 6 to 8 knots with proline, and you must be knowing that proline is a monofilament suture. So what are the examples of monofilament sutures? Mnemonic is pen, so we discussed. So here proline, ethylene, nylon. Okay. All these are monofilament sutures. Now see polyfilament. So it's poly, it means there are multiple strands, and these multiple strands are braided together. So these are braided together. Clear? The advantage is that this suture is easy to handle. So this is easier to handle. Another advantage that the knots are stable. Knots are stable. So generally how many knots we take? We take 3 to 4 knots. But the problem that there is presence of crevices between the strands, and because of these crevices there is increased risk of infection. So there is increased risk of infection. Yeah? So indirectly this question will be asked that if there is evidence of infection, or we are suspecting that the wound will be infected and we are supposed to put the suture, which one is preferred? To prevent infection, surgical site infection, which suture should be preferred? It's the monofilament suture, right? What are the examples of polyfilament sutures? So how to remember? The mnemonic is SLIM. Okay, so you can easily understand S silk, linen, and P is polyglycolic acid, also known as Dixon. So S, that is silk, this is linen, and this is polyglycolic acid. And what is the other name? It's the Dixon. Yeah? So it's very easy to remember because you know the mnemonics. Now if you have seen the trend of or pattern of questions from the last 5 years in AIMS, NEET, and in INI CET, you have noticed that almost every year there is minimum one question from sutures. Minimum one. And what kind of questions are asked nowadays? These are image-based questions. Generally, they give the image of suture or image of packet of suture. And what is the good thing about the packet of suture? That the suture name is already written on the packet. So it's very easy to identify. So one by one we are going to discuss. Let's first discuss the catgut. Now see, this was the image-based question in NEET PG. Can you see here? It's written. What? It is catgut. So be careful. Catgut is not the catgut. It is the sheep gut. Which part of sheep gut? Ileum. Which layer of ileum? It is the submucosa. Okay. So see the questions related to catgut. It is prepared from, first who discovered catgut? John Hunter. Clear? So it is prepared from sheep gut. Which layer? It's the submucosa. So it is prepared from submucosa of sheep's ileum. Generally, sheep's ileum. Okay. You know that this is absorbable suture. What kind of? Natural absorbable suture. And if you have opened catgut in the OT, you have noticed that there is a fluid or liquid in which this catgut is immersed. So it is having a preservative solution, having good smell. So why there is preservative solution? Because it is natural absorbable suture. If no preservative will be there, it will be degraded by bacteria. So question, what is that preservative solution used? So it is isopropyl alcohol. Isopropyl alcohol. Clear? This is frequently asked question. So preservative solution is isopropyl alcohol. After that there are two types of questions asked. One, that tensile strength of suture is lost in, and second, the suture is absorbed in. These two are two different questions. So that's why in exam you have to read the question carefully. That whether in the question tensile strength is lost is asked, or in how many days suture is absorbed, this question is asked. So if you see catgut here, the 50% tensile strength, it is lost in 3 days. So 50% tensile strength is lost in 3 days, and all tensile strength is lost in 15 days. Clear? So this is the question related to tensile strength. Now see the twist. Suture is absorbed in how many days? 60 days. So if the question is asked, the suture is absorbed in how many days? It is absorbed in 60 days. And this is the question which is most commonly asked, that in how many days catgut is absorbed. So it is absorbed in 60 days. Now see, whenever this catgut is tanned with chromium salt to improve the handling of suture and to resist the degradation, this catgut is known as chromic catgut. Okay, chromic catgut. Clear? So it is self-explanatory here. Catgut is tanned with salts. It is tanned with chromium salt. Clear? And what is the advantage? Why? To improve the handling. It improves the handling. Clear? And it resists the degradation. So it resists degradation of suture in tissue. Resist the degradation of suture in tissue. Now, in how many days tensile strength is lost? It is 21 to 28 days, and the suture is absorbed in 60 to 90 days. So here, tensile strength, it is lost in 21 to 28 days, and the question which is asked, that the suture is absorbed in 60 to 90 days. Now see this suture, it's already written. What's the name of this suture? This is vicryl. And what is the other name of vicryl? It's polyglactin. Now how to identify this suture? You can see what is the color of this suture. The color of this suture is violet. Okay. And if you see this suture carefully, can you see that there are multiple strands braided together, and simultaneously can you see that there is a space, there are spaces, these are known as crevices. So what kind of suture is this? This is monofilament suture, or this is a polyfilament suture. So vicryl is a polyfilament suture. Okay. So it's vicryl. What's the other name of vicryl? It is also known as polyglactin. Polyglactin. So it is copolymer of poly copolymer. This is copolymer of G glycolide, glycolide, lactin, lactide. Clear? So it is copolymer of glycolide and lactide. Clear? It is delayed absorbable suture. So it is a delayed absorbable suture, and its tensile strength is maintained for 28 to 30 days. So its tensile strength is maintained. This is maintained for 28 to 30 days. Clear? Okay. And if you have seen general surgeons, especially in OT, whenever we are operating or doing some kind of laparotomy resection anastomosis, generally general surgeons are shouting for a suture. Which suture? Vicryl, 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 vicryl. So this is the suture which is considered as workhorse suture for general surgeons. So vicryl is the workhorse suture for general surgeons. Simple. Now, there is one important question, that the organs in which there is stone formation tendency, like bile duct, ureter, bladder. So the organs in which there is stone formation tendency are the organs in which stones are formed. If we are supposed to use the suture for those organs, which type of suture should be used? It should be absorbable suture or non-absorbable suture. So obviously we cannot use non-absorbable sutures for these organs like CBT, ureter and bladder, because if you are using non-absorbable suture, what will happen? It will act as a nidus, and what will happen? There is stone formation. That's why in these organs we are using absorbable suture. And what kind of absorbable suture? Delayed absorbable suture. And which one? Vicryl. So generally this vicryl is used for these organs. So vicryl is a delayed absorbable suture. That's why it is used in CBD, it is used in ureter, it is used in bladder. Right? So how to remember? The mnemonic is CUB. So mnemonic is CUB. Clear? So it is CBD, ureter and bladder. Now see this image, and you can see on this packet what is written? Monocryl. So this is monocryl, and monocryl is also known as polyglycaprone. So the name of this suture is monocryl, and it is also known as polyglycaprone. Glycaprone. Clear? So poly, it means it's a copolymer of what? Gly. Here how to remember? Glycolide and plus caprone. So this is caprolactone. So it is the copolymer of glycolide and caprolactone. Clear? This was the image-based question asked in AIMS. And what was the question? That which of the following suture is used for subcuticular suturing? So this is the suture which is used for subcuticular suturing. And this monocryl is absorbed in 90 to 120 days. So two important questions. It is used for subcuticular suturing. Subcuticular suturing. Clear? And it is absorbed in 90 to 120 days. Next is polyglycolic acid. Polyglycolic acid. Okay? The suture. And this is also known as Dexan. Clear? So first, it is polymer of polyglycolic acid. So this suture is polymer of polyglycolic acid, and we discussed that polyglycolic acid is a polyfilament suture. Now the problem, we discussed that in polyfilament sutures there is increased risk of infection, and especially what is the big problem with this suture? Especially that this suture exhibits highest affinity for adherence to E. coli and Staph aureus. This suture exhibits highest affinity for adherence to E. coli and Staph aureus, and you must be knowing that this E. coli and Staph aureus are two important pathogens responsible for infection in surgery. Right? So what is the biggest problem with this suture? Dexan, that first it's a polyfilament, that's why there is increased risk of infection. And the second problem, there is highest affinity. Suture is having highest affinity for adherence to E. coli and Staph aureus. Clear? And this suture is absorbed in 60 to 90 days. So suture is absorbed in 60 to 90 days. So what are the two important questions which are asked? That this suture, Dexan, is having highest affinity for adherence to E. coli and Staph aureus, and it is absorbed in 60 to 90 days. Now there is a suture which is having lowest affinity for adherence to E. coli and Staph aureus, and that suture is absorbed in 180 days. And what's the name? This is PDS, also known as polydioxanone. Now see, this is polydioxanone, also known as PDS. Clear? Important point, that this suture is having lowest affinity for adherence to E. coli and Staph aureus. So one advantage, it is associated with lesser risk of infection. And what is the second advantage? That it is absorbed in 180 days. It means this suture is specifically used for those anastomosis where there is increased risk of anastomotic leak. So if you remember Whipple's procedure, in Whipple's procedure we discussed that at pancreaticojejunostomy, which anastomosis? Pancreaticojejunostomy is having maximum risk of anastomotic leak. So at pancreaticojejunostomy, which suture we use PDS. Right? So it is absorbed, you have to remember, absorbed in how many days? 180 days. Clear? And that's why it is used in Whipple's procedure, especially for which anastomosis? We use it at pancreaticojejunostomy, at PG. Now see, what's the name of this suture? Can you see here? It's proline and it's written polypropylene. So the name is proline. It is also known as polypropylene. Okay. It is monofilament or polyfilament. So it is monofilament, absorbable or non-absorbable suture. So this is non-absorbable suture. So this is monofilament and it's non-absorbable suture. Clear? Now you can see here that one artery forceps is being applied here. If you have seen that whenever we are using proline, especially you have seen it during suturing of rectus sheath in laparatomy, so you notice that at one end of the suture, mosquito forceps are being applied. So why we apply the mosquito forceps? Because this suture is having very strong memory. What is the meaning of memory? Memory means tendency to return to its unpackaged state. So what are the problems or disadvantages of this suture, proline? That it is having strong memory, it is having poor knot security. So strong memory, there is poor knot security, and there is lack of elasticity. Lack of elasticity. Here, these are the disadvantages. But we want to convert disadvantages into advantages, right? So since there is lack of elasticity, right? So we can use this suture for airtight anastomosis, and the airtight anastomosis is required where? It is required in cases of vascular anastomosis. So this suture is used for vascular anastomosis, and this question was asked in NEET. So what are the uses of proline? We discussed that it is used in vascular anastomosis because it can create watertight anastomosis, and second, we use proline for rectus sheath. For rectus sheath. So these are the important questions related to sutures. Now two questions which are frequently asked, that which suture is absorbed in how many days, and at this particular site and in this particular anastomosis which suture is used. So see the questions. So first, sutures which are absorbed in 60 days. So we discussed suture is absorbed in 60 days. Yes, it's the catgut. Second is 60 to 90 days. So the sutures which are absorbed in 60 to 90 days, and the mnemonic is VCD. Okay, so discuss B mitral, C chromic catgut, D Dixon, and the other name of Dixon is polyglycolic acid. So this is mitral, this is chromic catgut, and D, this is the Dixon, also known as polyglycolic acid. Then 90 to 120 days. Clear? So we discussed monocryl, also known as polyglycaprone. So monocryl, also known as polyglycaprone. And what was the question we discussed? That this monocryl is used for subcuticular suture. And 180 days we discussed just now, which suture is absorbed in 180 days, and this is PDS, also known as polydioxanone. Now see, the site and the uses of suture. So generally for skin suturing, which suture is used? Silk. So see, silk. What is the use of the silk suture? Generally we use it for the skin. We discussed what is the use of mitral, and we discussed the mnemonic also. It is used in the organs where there is stone formation, and the mnemonic was cup, C means CBD, U means ureter, B means bladder. So this is CBD, ureter, and bladder. Okay. Then we discussed proline. What's the use of proline? It is used for vascular anastomosis. Vascular anastomosis. And what else? It is used for suturing of rectus sheath. So this is used for rectus sheath. Simple. And for tendons, which suture is used? For tendons, we use nylon, right? So nylon. Nylon is used for tendons. Now, if you have seen the question of AIMS and NEET, nowadays they started asking the suturing principles also. Means, suppose you are going to perform the laparotomy, right? And you are going to give any kind of skin incision, and suppose the length of incision is X, what should be the length of suture? So this is known as Jenkins rule, right? So one by one, we are going to discuss the important points related to suturing. So first, what is the Jenkins rule? Clear? So if the length of incision is X, what should be the length of suture required? 4X. It means it's the ratio of suture length to wound length. So ratio of suture length to wound length, and this should be 4:1. Now, suppose there is elliptical incision. So this is the elliptical incision, and you want that the healing should occur without tension. And if the width of this elliptical incision is X, the width is X, what should be the length of incision? So it should be 3X. So for elliptical incision, you want that healing should occur without tension. So the length to width ratio should be 3:1, right? So second important question, for elliptical incision to heal without tension, length to width ratio should be 3 is to 1. Now see, whenever we are going for skin suturing, imagine that you are going for skin suturing after laparotomy, and these are the sutures which are being applied. Can you see? These are the sutures. Clear? And see, this is the thickness of skin. This is the skin thickness. Skin thickness is x. If the skin thickness is x, what should be the distance between the sutures? Yes, so it should be 2x. So for skin suturing, what is the ratio of distance between the sutures to the skin thickness? So here you can see the skin thickness is x and the distance between sutures, this is 2x, right? So for skin suturing, the ratio of distance between sutures to skin thickness, and that should be 2 is to 1. Clear? So it is very easy to remember. According to Jenkins rule, suture length to wound length ratio 4 is to 1. For elliptical incisions to heal without tension, length to width ratio should be 3 is to 1. And for the skin suturing, distance between sutures to the skin thickness ratio should be 2 is to 1. Now we are going to discuss the types of knots. Okay, and these are being asked